Hi friends, very good morning. Welcome to Anu Academy. Very good morning friends. In today's class in our channel, we are going to discuss soil mechanics and foundation engineering subject. So this is for your AE exam conducted by Andhra Pradesh Public Service Commission. Okay, so it belongs to paper 3 and paper 3 is common for environmental engineering and civil engineering. Okay, so let us start today's class. If you have not subscribed our channel, please subscribe our channel. Please like and share our channel. Okay, so we will start friends. Now we'll start our class. Material is ready. Okay, IAS classification of soil is in many respects similar to AASHTO classification, textural classification, unified soil classification, MIT classification. So the answer is unified soil classification. The maximum size of particles of silt is 75 mu, 60 mu, 2 mu, zero point 0.2 mu. So it is 75 mu. The maximum size of particles of clay is 0.2 mm, 0.02 mm, 0.002 mm, 0.0002 mm. So the answer is 0.002 mm. According to IS classification system, the soils can be classified into 15 groups, 18 groups, 3 groups, 7 groups. The answer is 18 groups. The soils which plot above the A line in the plasticity chart are clays, slits, sands, organic soils. Answer is clays. A silty soil gives a positive reaction in toughness test and dilatancy test, toughness test, dilatancy test, dry strength test, none of the above. See, the answer is dilatancy test. A soil has the liquid limit of 30. The corresponding plasticity index given by the A line is 7.3, 7.5, 9.0, 9.5. So the answer is 7.3. Okay. Now we will continue friends. Okay. The maximum value of the term F15 in the group index is taken as 20, 30, 40, 60. The answer is 40. The permeability of soil varies inversely as square of grain size, as square of grain size, as grain size inversely as void ratio. So the answer is as square of grain size. The maximum particle size for which Darcy's law is applicable is 0.2 mm, 0.5 mm, 1.0 mm, 2.0 mm. So the answer is 0.5 mm. According to USBR, a soil with a coefficient of permeability of 10 to the power 4 minus 4 mm per second will be classified as pervious, impervious, semi-pervious, highly pervious. So the answer is semi-pervious. The coefficient of permeability of clay is generally between 10 to the power minus 4 and 10 to the power minus 2 mm per second, between 10 to the power minus 5 and 10 to the power minus 4 mm per second, between 10 to the power minus 5 and 10 to the power minus 8 mm per second, less than 10 to the power minus 8 mm per second. So the coefficient of permeability of clay is generally between, answer is between 10 to the power minus 5 and 10 to the power minus 8 mm per second. Okay, now we will continue today's class. See, a constant head parameter is used for coarse grained soils, silty soils, clay soils and organic soils. So it is used for coarse grained soils. The coefficient of permeability of a soil increases with a increase in temperature, increases with a decrease in temperature, increases with a decrease in unit weight of water, decreases with an increase in void ratio. So the answer is increases with the increase in temperature. Okay, a soil has a discharge velocity of 6 into 10 to the power minus 7 meter per second and a void ratio of 0.50. Its seepage velocity is 18 into 10 to the power minus 7 meter per second, 12 into 10 to the power minus 7 meter per second, 24 into 10 to the power minus 7 meter per second and 36 into 10 to the power minus 7 meter per second. So the answer is 18 into 10 to the power minus 7 meter per second. In a pumping out test, the drawdown is 5 meters. If the coefficient of permeability of the soil is 10 to the power minus 4 meter per second, the ratio of influence will be about 250 meters, 300 meters, 150 meters, 200 meters. So the answer is 150 meters. For a sphere of 0.5 mm diameter, the specific surface is 12 mm to the power minus 1, 6 mm to the power minus 1, 8 mm to the power minus 1, 9 mm to the power minus 1. So the answer is 12 mm to the power minus 1. Okay. Again, we will continue, friends. Pneumatic tide rollers are useful for compacting cohesive soils, cohesionless soils, both A and B, for soils in confined space. So the answer is both A and B, that is cohesive soils and cohesionless soils. Next, vibratory rollers are best suited for compacting coarse sand and gravels, silts, clays, organic soils. So the answer is coarse sand and gravels. Okay. So next, pre-compression method is used for compacting silts, clays, organic soils, all of the above. So the answer is all of the above, that is silts, clays, organic soils. Okay. The line of optimums generally corresponds to percentage air voids of about 0%, 5%, 10%, 20%. So the answer is 5%. The range of optimum water contents for the standard Proctor, Proctor test for clay soils is 6 to 10%, 8 to 12%, 12 to 15%, 14 to 20%. So the answer is 14 to 20%. Soil compacted dry of the optimum as compared to that wet of the optimum has less permeability, swells less, shrinks less, has less resistance to compression. Okay, so that's all, friends, for today's class. I think today's class will be very helpful for your AE preparation, okay, conducted by Andhra Pradesh Public Service Commission. If you need any additional information, if you are having any doubts regarding this subject, please post in the comments box. I will give you a reply. Okay, if you have not subscribed our channel, please subscribe our channel. Please like and share our channel. Okay, so thank you very much. Thank you for watching.